Thank you very much for all joining in this online lecture series. This presentation is going to made by Dr. M. Ramakrishnan. He's going to his paper. This paper is being accepted already in Statistics and Application. It will be published in the forthcoming issue, volume number 24 and issue number 1. And he's going to present his work in his paper, Competing Risk Analysis of Factors Influencing the Runs Scored by Top T20 Batsmen, a Survival Analysis Approach. Professor Ramakrishnan, please go ahead.
Thank you, Professor. So first of all, I thank Statistics and Application for accepting my paper. And also I wish to say the motivation of this work is received from the same journal, Statistics and Application. So your issue 20 and 23, the Shaw et al. Published a paper evaluating batsmen using survival analysis. That paper motivates me to do many research using survival analysis in the part of the cricket, because I published the many paper in survival analysis using medical data and Nifty 50 data and any share data, anything. So after that paper only it motivates. So I thank Shaw et al. In this forum and also Statistics and Applications. In the paper Shaw et al. He taken the one-day international top 10 players in the world and used the techniques in the survival analysis, just non-parametric technique, Kaplan-Meier method of estimation, and comparing the survival distribution using log rank test and other tests. And also he used semi-parametric analysis, Cox pH model, and also parametric models, the exponential, variable, log normal, and log logistic. And also he applied the conditional survival probability. Why I am telling means that paper motivates me to direct it to do this type of analysis in the another concept that is called the competing risk analysis. So that paper the Shaw et al. Has taken as only one event. One event as a if the player has a dismiss, they are taken, that is as a considered as a event. So the run scoring that is taken as a survival time. So, but what I thought is we have different types of models in the survival analysis. So the competing risk analysis also one of the part, multi-state analysis also one of the part. Among the multi-state analysis, we have recurrent event analysis also there. So what we thought, we means with the help of the Professor Viswanathan from Statistics in Presidency College HOD and my student M. Sathishkumar, why we go through, if there is any difference is made, the factors affecting the survival of the batsman. Survival of the batsman means how long they are in the crease and also how many runs they are taken. So that is the things we think it, why we can use it, the competing risk analysis, because the batsman is getting out by different ways. One is by bowled, another is by caught, another is a stump out, run out, many things are there. So overall, the Shaw et al. Consider also out, but we consider it as a bold is our event of interest and taking other as a competing risk. So similarly, if you consider the caught as our event of interest, we consider other things as our competing risk. So this way, I wish to take the data. So the difference between the, while handling the completing risk analysis, by go through the Pindley book 2006, there is a great help for me to do many things through competing risk. So that is also helped me. So we have, because of the independence assumption of the censoring, while using the competing risk, it affects. So therefore, instead of using Kaplan-Meier analysis, so here we use the cumulative incident function. So there is a curve, Kaplan-Meier curve. Here they are using the cumulative incident curves for if there is any significant difference among the pattern. of the, if you are considering the innings as your covariate, so they are batting first or batting second, batting first or facing. The two things are there. So is there is any significant differences exist or not? So similarly, when come to the Cox proportional hazard model, semi-parametric hazard model, if you keep it as a only one event, we can go for the standard Cox proportional hazard model. But when it is comes to the competing risk analysis, we have two type of methods are there. One is called cause-specific hazard model. Another one is called as a sub-distributional hazard model. So these are all things we keep it in our mind. We have taken a data from cricket ESP info, and up to 28th April 2025, we have taken data. Those top T20 batsmen, they're ranked by the ICC, top 10, and also we consider the number of, at least the players should played 50 matches. So, and also if I am explaining about all the 10 batsmen in my paper, it will be get more. Therefore, we have taken the number 2 batsman. Number 2 batsman is a Josh Butler from England, and the number 5 batsman, this is a Babar Azam from Pakistan at the time. So 28th April 2025, he is in the 5th position in my ICC ranking. So on the 8th one, Mohammad Rizwan. So I taken the 3 batsmen. So one is Josh Butler, another one is Babar Azam, the third one is Rizwan. So then we have taken the many covariates. So innings mean batting first or chasing, how they are positioned, the top position, 1, 2, 3, if you are placed mean top position. So 8, 9, 10, 11, if they are played in that position is taken as a lower order, other order as a middle order. Then the match place. These are all things I got it from the ESPN info only, the website. So therefore, here match place, they are played in the home town or opposite town or neutral town. These also affect the performance of a player or not. These are also going to check. So the toss also the important things. The time of the match is also important things. So, but when considering the competing risk, we have many dismissals. I told you, caught, bowled, run out, stumping out, everything is there. But many of the players are dismissed through only caught and bowled. Maximum players are dismissed through caught. So therefore, we have taken only the 2 events as competing events. One is caught and bowled. So therefore, the comparison is made with the help of considering the all the outs are considered as getting out is a 1 event, and then I go for the cause-specific hazard model and subdistribution hazard model. So that is also tested by the hazard assumption, also tested by the Sponnefield residual method. So here the general Cox, while considering this one, the Babar Azam while considering getting out in the Babar Azam, we observed among the 4 variables, because why we have taken the 4 variables, we have 4 innings, position, toss and venue. Others are not satisfy the assumption. So after getting satisfied these 4 things, so therefore here Babar Azam, the position and toss has made it as a significant variable for the Jaswada. But when it is taking the bold is here our event of interest, and considering other thing as a competing risk, using the cause-specific hazard model, then our significant variables change for the same Babar Azam, position and venue. When considering caught as a event of interest and taking other thing as a competing risk, then toss is a significant covariate. So our aim is there is any differences, significant covariates exist when considering whole out dismissal as a one thing, and other considering the competing risk or not. So, and the same subdistribution model we use for bold and caught when you is statistically significant. So that means, so we understood that there is a difference exists while handling the competing.
Dr. Ramkrishnan, you have about 2 minutes to conclude.
Yes.
Thank you.
So therefore, this is the thing. With the help of the hazard ratio, we can easily tell that when standing in the home ground, they are taking standing survival long in the place. That is also they are observed. The same thing we got it as a Muhammad Rizwan position. So what the position mean? Whenever they are sending the middle position, they are getting the out. Hazard is more. Hazard is more means that they are getting out easily. This is also same obtained for the first player, Josh Butler. But there is no significant covariates exist in the Babar Azam. So in our what we are going to tell in this provides useful. So if you consider the significant covariate, when we can place our player. So if you place the player Josh Butler and Rizwan in the top order, they will stand in the crease more when compared to the middle. So the same thing if they play in the hometown, they will play more. So therefore, when we are winning the if the Babar, the first player, Josh Butler, whenever the team loses the toss, he is standing more in the crease. These are the things we have observed. So therefore, this is the survival analysis technique is very much used in the study to getting the performance of the player. This result should give an idea for the management of the cricket team. So this is the very interesting things. We have taken only the few covariates. Many covariates are there. So hereafter we have to collect the many covariate, and also for the future study we can use it as a recurrent analysis also. If we have a data, we can take the person stepping out the 50 runs. This I mean after 50 runs, how long they are surviving. These are all the things are having some research gap also available. So we in the future study we are going to include everything. So this is the things we did it here. This is a nice motivation for us to do many things. So I thank the statistics and application team for giving me the nice opportunity to share my whatever we did it in our paper. Thank you.
Thank you, Dr. Ramakrishnan.